Hi, this is Raf Alvarado and welcome to Exploratory Text Analytics. In this video we're going to talk about your Exploratory Text Analytics Toolkit, by which we mean the basic collection of software, tools and choices that we'll be using to run the code that this course is built on. Before getting into that though, I want to describe what I will call the data science way of doing things and how we're going to approach the study of text analytics. This will help guide our approach to the choices that we're going to use. First thing is that in general, data science consists of a pipeline approach to solving problems that begins with asking a question and ends with creating a product of some kind. I call this pipeline QDAP for Question, Data, Analytics, and Product. And basically, it consists of four broad phases. So after the asking of a question, the posing of some sort of problem, something that frames what you're trying to do, there is the hard work of establishing the data. This means everything from discovering data to understanding its structure to wrangling it and transforming it, doing ETL, putting it into a database, and basically setting the table so that you can perform the next part of the operation, which is to analyze the data using various sophisticated methods. This is the whole array of machine learning tools that we've talked about in a previous video. And something that I think that distinguishes data science from other analytical fields is the focus on the product, as it were, the deliverable, which can be anything from a database-driven web application to an infographic to a document that is designed to translate the results of analysis and data wrangling into something that is in some sense actionable or leads to some kind of activity or in general adds value. Another part of data science is that we really take to heart this notion that we stand on the shoulders of giants. We inherit a lot of methods in this course. We do some coding from scratch. We focus on some core algorithms and do them from scratch. But by and large, we're also building on a ton of work that's been done in the area of natural language processing and machine learning. And we access this vast store of knowledge through libraries, program libraries that exist and are freely available and make the work of doing exploratory text analytics a lot easier and indeed possible. And our goal here pedagogically is we want to have an understanding but not mastery of the deep logic that informs every algorithm. That's a true understanding of the depths of information retrieval and natural language processing, computational linguistics, and the other antecedents to text analytics that I described in a previous video. A true understanding of all of that really requires, pursuing a PhD in this field. It's really quite deep and quite rich. Here, we're learning enough about it to know what we can do with it and to ask the right questions and to tweak the right parameters when we're working with these tools. Another principle that's very important is that we think in and through data. That is to say, we begin in this course with an understanding of what I call data as data. We don't begin necessarily from the mathematical point of view of thinking of an abstract conceptualization, formalization of a problem. We look at the data and we try to understand how the algorithms that we use and the formula that we use interact with that data. And to the extent possible, when we're trying to explain something, the logic behind something, rather than visual representations of abstract spaces, we'll often look at the data set and try to understand it at that level. I'm a very strong believer in the use of data models, relational models in particular, as a means of exposing the logic of data so that algorithmic processes that work on that data make much more sense. Finally, as we already know, given the fact that this course is a course on the study of text, and there are antecedents to the study of text that we've already described, ranging from 19th century text criticism to 21st century digital humanities. We rely heavily on domain knowledge in informing our work. So another way of thinking about the pipeline that we just described is in this way, as a much more granular series of steps through which data flows. After we have framed our question, our area of concern, we know what sort of data we're interested in, we begin with our sources. In the case of text analytics, we have lots of text sources in the world. They may exist in XML databases, corpora of Text Encoding Initiative marked up texts. They could be texts from Project Gutenberg. They could be a collection of newspaper articles, either in some curated space or perhaps scraped from a website. It could be reviews, wine reviews, book reviews. Sources come from many, many different formats. And the first thing we do is take that data, which is extremely heterogeneous, and we convert it to a common format that I call the text mining corpus format. This is a very basic format that we're going to look at in our next module that is used by lots of different text analytic tools such as scikit-learn, GenSim, and so forth, and we'll get into those. After that, we take that data in its primary form, its sort of most standard form, and convert it into what I call the ETA data model. It is a worked out, normalized model of the data in the corpus format, but it's much more granular. We have, for example, a table that contains a vocabulary, a table that contains a list of tokens in the text, and so forth. And once we've done that, then we proceed to the step of using natural language processing tools to further annotate and add value to our data, to further augment the database. We do things like look at part of speech, look at stop words, which I consider to be an NLP process. We look at stemming and lemmatization. We look at grammatical dependency, and so forth. From there, we move on to creating various kinds of vector space models. Again, something we're going to talk about later, that allows us, sets the table, as it were, for us to do all kinds of interesting analytical stuff. And there we apply and generate machine learning models using various tools, both unsupervised and supervised. As I've mentioned before, the emphasis is on unsupervised stuff, but we're also going to look at a couple supervised things as well. And then finally, we produce what I'm calling here visualizations. And here what I mean are applications that drive what I referred to earlier as human-in-the-loop interpretive processes, where human beings actually look at a reduced representation of both the corpus and the analytical results on that corpus, and are able to make interpretive judgments or see things they didn't see before in the text. Another way of looking at this pipeline is as a database-mediated process. I'm a very big fan of leveraging the database as the hub of the pipeline. Here I have a SQL database listed. It could be another kind of database, but I'm very much a fan of SQL because it allows for the development of principled data models. And here we see that the pipeline involves the database at every step of the process. After we acquire data and put it into machine learning format, we put it into the database. We also convert it into ETA format that I described, the model that we're going to go into. And then from there, we can do analytics, and the results of these analyses can then also be put back into the database and augment the appropriate tables therein. And finally, as we move to the product phase, the visualization phase, the communication phase, we have the database there as a foundation on which to build applications. For example, a database-driven web application could use this database and build something using a framework like Django or Flask, just to stick to the Python world. Our technology choices, as I've just mentioned or just sort of hinted at, are going to be framed around Python. There are a lot of great tools in R, and indeed in many other languages. You could even go back to Perl and do a lot of this stuff. The focus here will be on Python, however, in particular Python 3. I'll probably be using Python 3.6, but I'm not going to be using any of the newer functions that make a difference within the Python 3 series. We're going to be using Anaconda as our distribution. Anaconda is a group that packages Python along with a whole bunch of libraries and other tools like integrated development environments and so forth, and you download it to your system and it sets up an environment for you. It sets up some tools. It comes with a nice user interface called Anaconda Navigator that you can use to pick and choose tools and environments and libraries. It's very useful. And it's pretty much of a standard in the field. It's something along the lines of RStudio for R, although that's comparing apples and oranges a little bit. Next, we're going to be moving up in the stack, as it were. We're going to be using Pandas a lot. Pandas is a data frame-oriented library that allows Python to do things that one might be used to be doing in R. And we're going to be doing things in a kind of Pandas way in this class, because we want to think about our text data as data. That is to say, in a data-centric perspective, where the set of data is the unit of analysis, and the way we process the data we think of as a set of tabular and matrix operations, as opposed, for example, to thinking about the algorithmic processes that we perform as being for loops that work on individual lines of things. We'll get into that and what that means specifically. But we're taking a sort of an opinionated data-centric view here. And of course, this means using other libraries such as NumPy, Numeric Python, which is focused on linear algebra, SciPy, or Scientific Python, which provides a lot of libraries such as a statistics library and so forth, and other libraries as well. And beyond that, we're going to be using some specific text analytics libraries such as the Natural Language Toolkit, or NLTK. Scikit-learn has a lot of text analytics stuff, and then there's GenSim, which provides tools for developing Word2Vec models, topic models, and so forth. We're using these tools as opposed to something like spaCy, which many of you may have heard of, which is actually quite a good library, because we're going to be focusing on building algorithms from scratch. We're going to look at the motivations and the math behind a lot of these approaches, and then we're going to build our own algorithms from scratch to try to make sense of those higher level representations in order to understand them, so that you can understand what's really going on in terms of what parameters mean, what hyperparameters ought to be set, and so forth. And then we'll use libraries to make things more efficient. And in your final projects, you'll probably be using higher level libraries. Finally, this course is going to be using heavily Jupyter Notebooks. Jupyter Notebooks are a great tool for communicating code and showing the thinking behind solving a problem with code. I like them a great deal. They're very flexible. They allow you to do what Donald Knuth called literate programming. That is the interleaving of code with text and image, so that you actually end up with a document that is meaningful in both a computational sense, but also in a human sense, providing a narrative unit of understanding of what's going on.